Hey guys, we're going to do the test review for our test on Friday, the 4th of May. Determine what transformations were done, to the parent function f of x to obtain the new function g of x. State the domain, range, and asymptote for each function. Okay, so we started with log base 3 of x, and we went to log base 3 of x plus 3. Notice this plus 3 is outside of the function. So that means I moved the graph up 3. So the transformation was up 3. Okay? Now, the domain. Think about what domain is for the log function. You should remember what a log function looks like. It looks something like this. Okay? And it has an asymptote, usually at x equals 0. Okay? It usually has an asymptote at x equals 0. Okay, so let me ask you something. Does moving the graph up 3 affect my domain? No, my domain is still gonna, as left as it can go, is still gonna be x being 0, and it's gonna go to the forever to the right. So we can say parentheses 0 to infinity. Now look at your range. Does moving your range up 3 affect it? Well, it goes down forever, and then it slowly goes up forever. Is going up 3 more gonna affect a negative infinity to positive infinity? No, it's still negative infinity to positive infinity. Now let me ask you this. Our asymptote is at x equals 0. Does going up 3 affect an already infinitely long up and down line? No. So it's still x equals 0. Okay? Let's go on to number 2. Number 2, well, there's a negative in front of the log, so that means reflects x-axis. Reflects x-axis. And then this minus 2 is inside the log, so that means right 2. Okay? So that means right 2. Alright, so now think about how going right 2 might affect your log graph. Well, it would definitely affect my domain, right? My domain's not going to be from 0 to infinity anymore. Now it's going to be from 2 to infinity. And then think about your range. Is your range going to be negative infinity, positive infinity still? Yep. Still going to be all real numbers. I'm trying the funky R. Okay? Think about your asymptote. It was at x equals 0, but an infinitely long up and down line can be shifted to the left or to the right. So going right 2 will move it from being x equals 0 to x equals 2. Alright? Okay, let's get our third problem, which goes from log base 2 of x to g of x, which is 2 to the x. So I went from log to exponential. So that's a reflection across the line y equals x. Because that's how you do inverses, right? You reflect them across the line y equals x. So, does that affect my domain? Absolutely. Now I'm looking at an exponential graph. Okay? So for my exponential graph, that looks something like this. Well, what's my domain now? It's all real numbers. Well, what about my range? What is my range now? Well, now I have a horizontal asymptote. I used to have a vertical asymptote, but since I'm exponential now, I have a horizontal asymptote at y equals 0. So I go from 0 to infinity. Okay? Now let's talk about our asymptote. It's at y equals 0. Because exponential has a horizontal asymptote. Okay? Alright, let's go on number 4. Number 4 says, rewrite the following log as exponential. Easy breezy. Alright, first you start off by identifying the base. So we look at this as a log. We say, what is the base of the natural log? Base e. You raise it to the output, which is 12. That becomes your exponent. It equals your input, which was a. Bam. There you go. E to the 12 equals a. So this guy would be 7 to the x equals 65. This guy would be 2 to the 5th equals 32. And this guy, well, wait, I don't have a base here. If you see log and no base, it's understood the base is 10. So 10 to the b equals a. Over here, the understood base was e. Natural log means the understood base is e. ln means natural log, which means the base is e. Okay? Let's go on to problem 8. 8, we're just going the other way, from exponential to log. So we start off by writing the word log, and then we put the same base. So the base here is 3, so the base here is 3. Okay? Our exponent, alright, well actually hold on. Our output becomes my input, so that's 81. Okay? And my exponent becomes my output. So I switch my input and output, so to speak. Alright? So this guy is log base 12 of 34 equals x. This guy is log base 64 of 8 equals 1/2. And this guy is log base e. Woo, I don't want to write log base e. I want to write natural log ln of s equals r. So natural log of s equals r. See, instead of writing log base e, you should write natural log. You should write ln. Okay? Alright, let's move on. Next problem. Alright, next problem is problem 12, which says, use the laws of logs to expand. Ooh, I went too far. Use the laws of log to expand the expressions. Okay, so I have log base 2 of a to the 4th times b. Well, if you have two things multiplying inside a log, you can give them each their own log. Now they are adding. And exponents simply become coefficients. So it's going to become 4 log base 2 of a plus log base 2 of b. Okay, remember the 4 power that was on a, it goes out front and multiplies to the log. Alright, now this one, the x and 3 are dividing, so the x and 3 both get their own log now, but instead of dividing, they are now subtracting. They get their own log, where instead of dividing, they are subtracting. Okay, what about this one? There's a lot going on here. Well, everything is going to get its own log. If it's multiplying the numerator, it's going to be a positive log. If it's in the denominator, it's going to be a negative log. And the thing to remember is that powers will go out front in front of those individual logs. So we're going to say log of 7, because the understood base is 10, so I don't need to write it, plus 3 log of x minus log of y, because that was in the denominator, minus 2 log of z. Alright? So what about this one? Well, this one I have x times square root of y. Square rooting y is the same thing as raising y to the 1/2 power. So this is really y to the 1/2 power. So x and y are going to get their own logs now. So log base 2 of x plus, and this power of 1/2 that's on y, it's going to go in front of the log. So log base 2 of y. And there we go. All right, let's go to 16. Use the laws of logs to combine. So we're just going to go back the other way. All these are going to be put into one simple log. So we're going to have the natural log of 4 x cubed. And then I'm not going to actually write this out twice. I'm just going to write x to the 4th plus 5 squared. All right? And this is all inside the natural log. Okay? So this next one, these two things are subtracting. Okay? So I can make them one log where the two things are now dividing. So that becomes x squared minus 9 over x plus 3. Okay, problem 18. Alright, do you see how these two logs are both negative? So those two logs are going to end up in the denominator. Everything that's going to be positive is going to end up in the numerator. So we're going to get log base 6 of x squared, square root of y, because it's the same thing as raising y to the 1/2 power, over 2z cubed. Bam. That's it. Alright, let's go on. Went too far. Alright, solve the equations for x, show all work to receive credit, box answers. Okay. It's not a big deal if you box answers. This is a review. Alright. So first off, this is an exponential. We want to change it to log in order to solve for x. First thing I have to do is get the base by itself. My base is 3. It's already by itself. So I can start off by saying log base 3 of 7 equals 4x. And then the next thing you want to do is divide both sides by 4. Okay, and then you can just go punch that in a calculator. Alright, this is how you would punch in a calculator. You would need to go to math, scroll up and find log base, hit enter on that, and from there it should be pretty self-explanatory. I will have to do it in a slightly different way because my calculator does not have the log base ability that your newer calculators do. So I have to do log 7 divided by log 3, all divided by 4. And I get 0.44. So x is approximately 0.44. Okay? Alright, let's go on to the next one. E raised to the 4x minus 2 is equal to 100. Step 1, get the base by itself. It's an exponential right now, so to change it from exponential, in order to solve an exponential, you need to get the base by itself. E is already by itself, so I can change to log. Now when I do log base E, I don't write log base E, I write natural log of 100 is equal to 4x minus 2. Okay, so we had a similar problem. I think actually we had this problem yesterday. You need to solve for x. So you have the natural log of 100 equals 4x minus 2. Step 1, add 2. A lot of you guys accidentally made it 102. The thing is that 100 is trapped by the natural log. So the plus 2 has to happen out here, and then we're going to divide everything by 4 to get x by itself. Now this now is just one big calculator situation. So I can hit natural log of 100 plus 2 all divided by 4. I get 1.65. 1.65 is approximately equal to x. Okay? Next problem. Alright. 250 times 1.09 raised to the 5t is equal to 500. Once again, this is exponential, but the base, 1.09, is currently not by itself. You got to get rid of this 250 first. So we divide both sides by 250. Alright, these cancel, so I get 1.09 raised to the 5t is equal to 2, because 500 divided by 250 is 2. I now have the base by itself, so I'm going to change to log base 1.09 of 2 is equal to 5t. So then, to finish solving for t, I'm going to need to divide both sides by a 5. Once again, you guys would hit math, you'd scroll up to log base and make that magic happen. I don't have that ability, so I have to do what's called change of base formula. It's just kind of a pain. Alright. And then I want to divide this by 5. And I get 1.61. So, t is approximately 1.61. Alright, let's go on to our next problem. Natural log of x minus 4 equals 2. Okay, this one's a little bit different. Now we're no longer doing exponential, we're in natural log. Well, how do I solve for x when it's trapped by a natural log? Well, you have to change to exponential. But before you change to exponential form, you first must get the log by itself. So I first need to get this natural log by itself. So I need to add 4. That would be my first step. So I get natural log of x, equals 6. Because I added 4, 2 plus 4 is 6. Now I'm ready to change form. So what's the base for natural log? E. So I get e to the 6th is equal to x. And then if you want to see what that actual number is, you would get second raised to 6. 403.43. So you could say 403.43 is approximately x. Okay, next problem. Alright, another exponential. We switch back to an exponential there. So I first need to get the base by itself. The base is by itself, so I can now change to log base 9 of 6 equals x plus 1. Alright, so then what's the next thing you need to do to solve for x? You need to subtract 1. But remember that 6 is trapped by the log. You can't touch it. Okay? So, I'm not going to touch it. I'm just going to type it on the calculator. Once again, you guys would go to math, log base. You know the drill by now. You know that I have to do this annoying change of base formula. And then I subtract 1. And I get that x is equal to negative 0.18. 8 is approximately x. Okay? Let's go on to this next one. Log of 5x plus 10 equals 3. This 5x plus 10 is completely trapped by the log. So that means the log is by itself, so I can start off changing to exponential. So first I take my base, which is understood to be 10. I raise it to the third power. I said equal to 5x plus 10. Now I solve for x. 10 to the third is 1,000. So then I need to subtract 10. And then I'm going to need to divide by 5. That's going to equal x. 1,000 minus 10 is 990. I honestly do not know what 990 divided by 5 is. I know it's a whole number. I think it's a whole number. I'm pretty sure it's a whole number. 198. So I know that 198 equals x. Okay, last but not least, in the slightest, 2 log base 2 of 5 minus x equals 4. This 5 minus x is trapped inside the log, but I can get rid of the 2 first. So I need to divide everything by 2. So now I have log base 2 of 5 minus x equals 2. Now that I have the log by myself, I can change to exponential form. So I can say 2 raised to the 2 equals 5 minus x. Okay? So this is 4. So I have 4 equals 5 minus x. So now I need to finish off for x. So this is a positive 5. So I'm going to subtract 5 from both sides. I get negative 1 is equal to a negative x. And so I divide both sides by a negative 1 to get a positive x. So I get 1 equals x. Bam. Alright. Alright guys, that finishes up this review. Please let me know if you have any questions. Send me a remind, send me an email. Just, get a hold of me. Make sure you're ready for our test tomorrow, which is on May 4th. Alright? You guys have a great day.